Alright guys, in this video I'm going to be telling you about our next class of automata. Okay, so what have we done? We have previously done that. We know that language is depending on grammar. लैंग्वेज ग्रामर पर बेस करती है और ग्रामर में वर्ड्स होते हैं. अब इसमें वर्ड्स जो हैं वो टर्मिनल्स होते हैं. सो वी नो दैट लैंग्वेज बेस्ड ऑन ग्रामर and grammar has words and those words are leaves or terminals. Okay, now language is a four tuple set. It is a sentence with terminal and non-terminal members, you can say, with some procedural rules. Okay, and in other words, grammar is a set of grammar is a four tuple set which composes of sentence, terminals, non-terminals, and procedural rules. Language is a set of grammar, and words are have terminals, and the asterisk stands for spaces. Okay, so grammar. So we have already built that tree of grammar, and S is our starting point, and it's also called the root of the tree. Terminal points are leaves. Any node other than leaf is a non-terminal, and P is the parent-child relationship or the procedural rules. Now if we compare English language and if we compare your computer C language, if we have ABC, then we also have ABC in our C language also. Okay, I, as a student working on a project, this is an English language sentence. Okay, so apple, if there's a word apple in English language, if we see in terms of C language, then we know that apple can be converted into ASCII characters. A can be converted into 65, I guess is 67 or something. Okay, and ABC and to up till Z are variables, constants, keywords, and functions. Okay, then we know the source. Our source is A. Compiler construction में सबसे पहले ASCII define होगा. Our teacher told that if you want to build a compiler, then if we are going towards compiler construction, then we have to define. The first stage is to define the ASCII characters. How the compiler is going to know on what basis to build. Okay, then we have a source, and C language is, our teacher has done what he's done is, there are A and there are double A's and there are triple A's. And we know that the language is a set of grammar which is has words and those are terminals. Okay, now starting point. Now this is language 1. Sir has defined starting point of this language is B, and a non-terminal is also B, and a terminal point is A. So A, because here's also A is a member. Language के वर्ड्स में सिर्फ A है, इसलिए A लिखा है. Okay, that is, we have written a terminal point A. That is because language, the set in the language has A. Okay, now what are we gonna do? Now these are the rules of this specific scenario. So B can be further have A B. Now our teacher told, do not think at this stage. Do not think about how these rules. Just observe. At this stage, students are usually they are told not to focus on how the rule is built, just to focus on how the grammar is being done. Okay. So B there. Now you have actually given two options for the compiler to start the language is. Because this is a very initial stage, that is why we are doing this, we are starting from B. But in real life, if you give compiler or the 2 points to start, it is ambiguous, your program may crash, it's bad programming practice. Just because if we are studying here, that's where we have kept these two rules. Okay, now B in this case is root and A is a leaf. Okay, and if we see that B is a parent and A is a child, and B is also a parent, B belongs to B, because see, non-terminal starting point is B and non-terminal is also B. So non-terminal is B and B has a child A. So double A comes in and we can verify this double A, okay? Okay, now same goes for the triple A and so on. So you can see it's a recursive thing. Okay, don't confuse ये rule कैसा बन रहा है. अभी ये सही अभी ये सोचना है कि language से okay. B starting point कंप्यूटर को आज़ाद. Okay, कंप्यूटर को हमने आज़ादी दे दी है. Okay, so ये जो point है, this specific point, this is also telling, I've told you this, that you do not define the computer 2 points to start. It's a bad programming practice, just this. Okay, there's an MCQ. If null is concatenated with a word, if null, anything is null, and it's concatenated with a word, so the ultimate result is a word, and this property is called identity property. Okay, so we have our language here, and A is a set of n such that n is greater than or equals to 1. It's about this language, okay? So it can also be defined like this. Okay, and if there is null, then we can define as A as a to the power n such that n is greater than or equals to 0, because anything to the power of 0 is a null, and in automata, A to the power of 0 is a character and character is a null. The character of length 0, null key representation. This is the representation of null over here. Okay, if an MCQ comes in, you do like this. So इन्होंने यहाँ पे लिखा है 2 languages हैं, एक में null है, एक में null नहीं है. There are 2 languages, one has null, one does not have null, and the second one has. A to the power of 3 means AAA, and the character length is 3. Okay, now what are we gonna do is starting point is B, non-terminal point is B, and A and null is the terminal of this specific set. These are 2 procedural rules. B has this null, and A and B are leaves. So if you're gonna make a tree out of this, then A to the power 0 is null, and B can have a child A, and B can have a child B, A, and B can also have null. So the ultimate result is double A, and this would be our ultimate result, which accounts for double A, which is a part of our language. Okay, if you look at here. Okay, then we have is Clean's theorem, clean plus theorem and clean steric theorem. Okay, ये दोनों theorem हैं, null नहीं लेना. Okay, इसमें हम null भी ले सकते हैं, null से नहीं भी, if it depends. Okay, so we'll look into this situation for a while. Apply Clean's theorem. Apply Clean's theorem to this language. Null 1 0 1 0 0 1. Now the regular expression for this is null or 0. This is not plus. This is concatenation operator in theory of automata. Okay, and this 1 plus means that it can go by up till 10. Okay, so these two expressions are being multiplied. There's a dot over here. Where's my pen? Hold on a second. There's a dot right here. Okay, ये और लॉजिक है. 1 प्लस का मटेरियल मैटलैब एटलीस्ट 1 टाइम ले सकते हैं. Okay, this 1 plus means that we can take this one at least 1 time. We have to take it, and at most we can concatenate 10 times. Okay, so you can see that if this expression is also proved, your regular expressions should contain all of this. I'll give you an example. The null multiplied by 1. See, this is available. 0 into 1. This is available. 0 into 1 and another 1. See, because we can take up till 10 ones in concatenation. 0 1 1 1 0 1 1 1 1. Regular expression proved. Okay, what is here? K formula को automatic में regular expression आपके compiler में ये. Okay, if you want to build a compiler, you define the most efficient regular expression in order to your compiler. If you're using, I don't know, GNU plus CC5, whatever compiler you're building, By the way, G and UCC compiler is way out of my league and everyone's league. It's not a child's play. Anyways, so if you have been a compiler, then what you gotta do is you have to come up with a most efficient. There are tremendous amounts of expressions, but in the market we pay for the most efficient good. Nobody wants to buy a 40,000 lines of code app. Everyone wants to that Facebook app you're building. They want less processing power, less memory power, the most efficient thing possible. And with time, it's just like computers. They were so bulky and now they're like, so sleek. Okay. Then what do we have is this is our language 1010. Our regular expression would be this thing multiplied by this thing multiplied by this thing. Okay. Wow. I mean, when I understood this thing, I was like, man, what the fuck? Okay. 1 0 1 0 0 1 1 and so on. See, 1 and 2 nulls combined, this thing proves 0 1 and 0. This thing proves 0 1 1 0 and so on. See, this thing keeps proving. Then we have our language 3. The regular expression is this. Okay, this asterisk means that you can go by up to however many values you want. 0 0 0 1 0 1 0 0 0 1 0 and 1, because the center expression, forget this expression, just focus on this, the second one, this one. Okay, this one where my pen is. Okay, so 0 0 0 1 0 1 0 0 0 1 0 1, and there you go. This actually it's simplified into this thing. Okay, now this is language 4 and the regular expression is this thing. And if we have a language for prime, you have this. The regular expression is not possible. What is prime number? I've actually recorded and not in a position and because of so much time. ऐसे number जो 1 से. Okay, what is the definition of prime number? ऐसा number जो 1 से divide और अपने आप से हो. The other definition was वो number 1 के बराबर ना हो. Any number that is not equals to 1. And the second thing for any number to be a prime number is ऐसा number, a number which is divisible by 1 and by itself and not by any number is called prime number. Okay, so we can conclude that formal languages. Okay, right now this is if we want to define the regular expression for prime number, the regular expression is not possible. Okay, so languages in which regular expression are not possible are called non-formal language, and formal languages follow the grammar. Informal language don't follow the grammar. So formal languages, इनकी क्या मिसाल हो गई? Python, Java, C++, all are formal languages. Python, Java, C++, all are formal languages. And there is another set, L7, AN, regular expression is AN. It's so simple. A, B, B. However many times you take A, that many times you have to take B. AN is Pushdown Automata. This thing is called clean theorem. If you apply clean theorem and memory, if you concatenate, not concatenate exactly, if clean theorem and memory element comes in, then that automata is called Pushdown Automata. It's an MCQ. Just like a flip-flop in DLD, the flip-flop in, I don't know what, I'm exactly not remembering. There's one state in which it remembers that the last bit passed was 1 or 0, okay? So Google flip-flop, if you don't know about it. That's it, guys. Thank you for watching. And please subscribe to Talha Studios. I will be making videos like this, quick videos. Please keep supporting and I love you.